So today, so I would say this is like probably one of the more exciting lectures for your time at Flatiron. I'll try to like make it live up to the hype, but this is the intro to Active Record. We've been basically like spending the last week and a half, teaching you how to like build a car, right? We've been like giving you all the tools, figuring out like this is the engine, this is the wheels. Now we're gonna give you the keys to a Ferrari, so we're just gonna give you this like awesome new tool that somebody else built and show you how to drive it. An Active Record is gonna stick with you for like the rest of your time at Flatiron. It's going to be how we set up our classes, how we set up our models, and how we get them to communicate to the database and like do that persistence. So it's gonna be something that you get like a lot more practice with throughout your time here, but kind of getting like a good foundation, a good sense of the fundamentals, and understanding a little bit how it works under the hood will set you up for success for really the rest of your time in the program. So we're going to talk a little bit just in depth about like gems and how to set up a little bit of a bigger project. We're going to implement Active Record to connect to our models. We're going to work on like creating migrations and see what that is, what that does for us. We're going to use another tool called Rake to automate kind of tasks that we want to do a lot in Ruby. We're going to talk about models, classes, and tables. We're going to work again a little bit with like inheritance. So going back to that lecture on Friday that Otha did, so see how we can get some shared behavior from all of our classes. And then we're going to talk again about CRUD and how to do CRUD using Active Record. So before we start, there's like kind of one more under the hood topic that I want to go into, and this is going to be something that will be helpful for understanding like how Active Record works. It's something that'll come up again in Mod 2, so if I don't teach you about this now, your Mod 2 instructor, which is going to be Graham, will be upset with me. So I'm just going to give you like a quick demo of like this concept of mass assignment. And again, like the code that we're going to write for the next 10-15 minutes is just going to be kind of like yesterday, more of a understanding of how something works in Active Record. It's not going to be something that you will have to implement yourself. It should just be something that you understand. And when you hear these words, mass assignment, you should kind of know like what we're talking about. So to demo that, I have a little example code set up. So we can actually do my lovely like clown example this time. So we have a plain old Ruby class. We haven't started connecting anything to Active Record yet. This will just be how we've been working with our classes in the past. We have a class of clown that is initialized with a name, age, fears, and skill. All right, so we can create new clowns, kind of how we've always been creating our objects. One issue with this approach, even just like with this, the way we're initializing this class, and it might be something that like you've felt the frustration with already, is like if I don't have this code in front of me, if I'm not like looking at the clown class, it's kind of hard to know what order these should be in, like what these arguments are actually for, right? And really anytime you have a method that's got more than like one or two arguments, there's kind of a, this is kind of like a common problem. And the solution to that problem, like one way we can kind of make this code easier to read and easier to use in the future is by using a hash rather than using individual arguments. So instead of saying like 4 arguments in a row, just depending on the order, right, these will get assigned to the arguments when I'm calling initialize, I could say I want to pass in one argument, and that argument will be a hash. And that will just be some key value pairs that will make it a little clearer what these different values are for. So we could say this is going to be the name of Krusty, it will be the age of 2, it will have fears of children, and the skill is juggling chainsaws. Right. And just by like making this into a hash rather than putting the arguments, as 4 separate arguments, it makes this a little bit more flexible as well. Like I can change the order of these. It doesn't matter what order the keys and values are in the hash. Right. When I call initialize now, I just have to worry about, looking through that hash. So looking through like the args hash and pulling out these values. So instead of getting directly access to like the argument of name, I now have to look at the args hash at the key of name. All right. You can look at args hash at the key of age, key of fears, and key of skill. And this makes our code a little bit more flexible. Right? I no longer have to remember the order. If I created another clown, anybody know some famous clowns or unfamous clowns? It? Well, Pennywise, right? Yes, Pennywise. Right, so if I wanted to make Pennywise, and I didn't remember what order the arguments were in, I could say, first I know the name should be Pennywise. Age is 300. Very, very old. Any fears? Ridicule. Right? And skills, just like luring kids into sewers. So the idea is like by using this hash instead of by passing in just the arguments in order, it makes our code more flexible, and it makes it easier to read when we're seeing what this clown is being created with. Ruby is also nice. So if you're passing in just one argument and it's a hash, you can actually get rid of the curly braces. So the curly parentheses can go away, and it will still treat this as one hash that we're passing in. Okay. Let me get rid of this pry. Just run our code. So we can see this idea of like passing in a hash as an argument. So if I call Ruby example /massassignment.rb. All right, we'll talk about bundle momentarily. So if I call this like Ruby example massassignment.rb, right, this will let me create these clowns passing in a hash rather than just a bunch of arguments in order. And this works pretty well. Right. We can actually even take this one step further, because I see there's like a common, some commonality between the way these accessors are set up, right? This is a accessor for the name. There's an instance variable called name, and there's also in my args hash, right, a key of name. So what would be nice is like when we're initializing this clown, when we're creating new instances, if we had some way of looking through the args hash and using each key from the args hash to like set these instance variables. So some way of like dynamically looping through this args hash to get out these key value pairs. So let's give that a shot. So rather than assigning the instance variables directly, if we wanted to use some kind of like meta programming to figure out, based on what args hash are coming in, how we want to assign these instance variables and use our attr accessor methods. So if I run this again, when I initialize Krusty, right, we have access to this whole args hash. And what I want is to take each key from this args hash and use that to set the value for an instance variable. So going back to working with hashes, if I wanted to go through each key and value from a hash, if I wanted to like iterate over this hash, how could I do that? Yeah.
Would we go through the entire hash, or are you just picking out?
Yeah, so go through the entire hash, go through each key and value.
You can do for what purposes? Do you want to return them all?
I just want a way of iterating through them.
Okay, you
for
can
now.
do a dot each.
Yeah. Cool. So if I do a dot each, right, when I do dot each, I get back
Key value pairs.
right the key and the value as the block parameters. Right. So for now, I'll just like print it out so we can see what we're getting. So print out the key, print out the value. Right, so this will let me loop through this hash, getting back, key of age, value of 2, key of name, value of Krusty, key of fears, value of children. Right. So this is like how we can loop through this hash, iterate through the key value pairs. Awesome. So I'm going to move our binding.pry inside of this each. Right. And the next step we kind of want to do is for each key and value, instead of just treating this as like a static value, instead of saying like every time we want to set this specific variable, I kind of want a way of setting whatever the key is, right? Whatever like this clown instance's key is to that value. So I kind of want something like this where key is like dynamic, right? So the first time it goes through, it would be name. Second time it goes through, it would be age. Third time it goes through, it would be fears. Okay. So if I set it up like this, if I just do like self.key equals, what's this going to try and run? Like, how is Ruby going to interpret this? Any guesses? Should just hit the binding price, see what happens. Yeah.
Well, self is what's the name? The whole passion instance. So passing through.
Self in here would be the instance of the clown that we're creating.
Right.
Yeah.
That instance, and so you just you're making that equal value, so that every time you create something, you don't have to just like every time you create something, it'll be initialized.
Yeah, so this is kind of like what we want to happen. There's going to be like some errors we run into with this approach. So let's see what that looks like. So right now, I'm in this initialize. I'm in this like binding.pry. We're creating a clown, and we're in this instance method for initialize. So self is the clown instance that we are currently creating. We have access to the key, right? So the first key is age from this hash. The second key, or the first value is 2. Right? So this is coming from this args hash. And what I want is a way to basically call like self.age equals and set it to that value. But if I try to do like self.key equals value, what's going to happen? Any thoughts?
Or I just have a question.
Yeah.
I feel like I missed something. How did we pass in, like it looks like we're dealing with the crusty hash, or the, like I'm just wondering, where did we pass that in?
So right now, args hash, right, this whole args hash that we're calling with initialize
Yeah.
is this hash right here. So when we're calling crusty.new, Ruby's going to treat this argument as a hash.
How did we pass in crusty though versus Pennywise?
So this is just, we're in this like binding.pry in initialize when we're initializing crusty. So I called clown.new. Clown.new will call our initialize method. So right now we are frozen in time on line 8 while we are creating crusty.
Yeah, I just don't see where we started like making crusty, or is it just because this is the first one and like Pennywise will happen second because it's lower down on the page?
Yep, we're just at line 18.
Okay, so we just stopped at line 18. We're not like at line 6, like, or like we jump back into that, but like within line 18.
Yeah. So we ran the code on line 18. That ran clown.new. Clown.new ran this initialize method.
Okay, cool. Yeah, because I was like, I don't see you like passing crusty into like the initialize thing, or I was just like not following how we got into that.
Cool.
Okay.
Yeah. So this is what we have access to. Right. So we're initializing crusty. So self is the clown instance that's currently being created. Right. We are inside of this like iteration. We're going through this args hash. So the first time we're going through, we have the key of age, the value of 2. Right. And I want to be able to like basically dynamically call methods based on what this key is. So the first time I want to call age, the second time I want to call, the first time I want to call, age, then the second time I want to call name, third time I want to call fears, fourth time I want to call skills. Yeah.
So can we use like conditionals to specify like if the key is equal to this, then like assign the value to be something else?
So if we wanted to do like conditional logic, it probably wouldn't save us lines of code. It would it would just be just as complicated as like writing something like this out.
Okay.
I mean, what we really want, like the last step, is just being able to like dynamically call a method, like self.key equals, where key is dynamic, right? Where key changes depending on what we're iterating over. So self.key equals value won't quite work. it's just going to call, it's going to look for like a literal method called key equals. So there's one tool that I showed very briefly during like a lecture a week and a half ago that will let us do this. And that tool is called send. Right, so if we want to be able to like dynamically send different messages or like call different methods on something, right, if I have a string and I wanted to send a method of length to it, I could do it like this. Right, this is the same as me calling hi.length. I could also send string of reverse, call like hi.reverse. Right, and the good thing about this, like the good thing about this approach is we can make this argument, like whatever we're calling with send, dynamic. So if I did like self.send and I pass in our key, right? I pass in age, it'll give me back 2. So this is getting closer. What I really want is to send the like age equals method and pass in the value. So only thing I need to do to make this dynamic and say, based on what key we're setting, right, call that writer method, use that, the writer we get from this adder accessor to set this value based on that key. So this is how we can do this concept of like meta programming using mass assignment. Say based on like what arguments we're getting in this hash, we can call this writer method dynamically using send, right, to set some key equal to some value. So if we exit out of here, rerun this code. When I look at Krusty, I can see it was initialized with this hash using this kind of like mass assignment technique. And same for Pennywise. So instead of like manually hard coding in what we are setting the instance variables to, we can use this technique to dynamically set it using the keys from this args hash. And I would say like this is about as abstract as we're going to get. This is like as deep as we're going to go into metaprogramming in Ruby. And really like this is again just a peek under the hood of what Active Record is doing. So if this doesn't make 100% sense, if you're not able to recreate this code on your own, that's totally okay. Just this is more like demo purposes. All right, cool. Okay, so that is mass assignment in a nutshell. Now we're going to get into the Active Record portion. So first off, we have like a little bit of a bigger project setup than we are used to probably. Like there are several different folders, even ignoring this example folder. We have a new file, this rake file. So I'm just going to walk us through everything and kind of answer questions about how this is all set up before we start writing the code for this. So first thing we have is like this gem file, and we have a lot more gems. Right? We have some that are probably familiar. Right? We have pry, which we've been using kind of since day one for debugging purposes. We have this like SQLite gem, which we started using yesterday for communicating with the database. We have require all, which will let us more easily like require files in a directory. So these are all things that we have seen before. The new gems today are Active Record. Right? This is the actual like Active Record code that will let us do all of this magic connecting our classes to the database. We have Sinatra Active Record, which will give us some rake tasks to more easily like automate some of the steps that we're going to be doing. And then we have rake, which is I'll explain next. So these are all of the gems for this project. To make sure we actually have these gems installed in our system, and this is just a good habit to get into basically anytime you're getting new Ruby code. If you like clone down a repo that has a gem file in it, just get in the habit of running bundle install, or just bundle, which will do the exact same thing. This would make sure if you don't have these gems already installed, it will download them for you, and it will set up this gemfile.lock to make sure you have all the right versions. we have access to all these gems now. The other things we have are a DB folder. So this is going to be where we start organizing all of the code for connecting to the database. So the actual like database will go here, like our SQLite database, as well as kind of the instructions for telling Active Record how our database is set up. We have a config file. So this config file will kind of like we've been doing before, just set up all of the code that we need to run everything else. So bundler.require will require all of the gems in our gem file into the project. This will create a connection with our database file. So this like db development.sqlite. This will let Active Record know where we're keeping our database and what kind of database it is. So we're going to be using like SQLite for all of Mod 1, but you can also use different database applications like Postgres or MySQL. And then we are going to use this, you can log the output. So when you're like running Active Record, you can see what SQL it is creating for you by enabling this logger. So this will let us see like when I run the Ruby code, what SQL is getting generated for our database. And then just requiring all of the folders in our app, or all the files in our app folder. Right. And our app folder has a models directory where we'll keep all of our models, but nothing else as of yet. So the last new thing about these projects, we're starting to use these things called like a rake file. And a rake file is really just a place where we can write some code that we want to run, like kind of repetitive tasks that we want to do in our application. So this is going to kind of take the place of that, like, just adding like a binding.pry in a tools config file or something like that. We can run like a console from here. You can also just create whatever rake tasks you want to do. And this is just going to let you write whatever Ruby code you want and run it from the command line. So if I wanted to make an app that was something I want to do a lot is print out some cowboys to the screen. So I'll make this my cowboy printer. And this will just put some emoji. Where's my cowboy? There we go. 100 times to the terminal. So this is something I want to do a lot. This is like a task I'm going to need in my life. So the way I can get it to run this Ruby code, right? Instead of calling like Ruby rakefile.rb or something like that, I can just call rake and then tell it to run my cowboy printer. Right. So whatever Ruby code you have inside of here, you can run a little bit more easily from the console rather than calling like Ruby run this file. I'm going to comment this out for a second, just so we can see. You can also see like what rake tasks are defined by calling rake -- tasks or rake -t. And this will tell you, what rake tasks you can run from the from your terminal. So if I run rake console, this will start a pry session. This will like hit my pry.start, so we can just run whatever code we want. So this will be kind of replacing that like tools/console.rb file that we've been using. We also get a lot of like rake tasks from this Sinatra Active Record gem. And this is what we're going to be using to do a lot of the setup for our database. Right, so before, when I had this line commented out and I ran rake -t, I just have like the 2 rake tasks that I manually defined in here. When I run rake -t with this line required in, I now have like a whole bunch. So all of these are going to be tasks that we use to manipulate the database. All right. Cool. So that is like our project setup. And that's how we can use some rake tasks. So the next thing we're going to do, all right, let's figure out a domain that we want to work on. So we could do the games and players domain that we were working on yesterday, where like a game has many players through reviews, If you want to come up with something else, we could do like a many-to-many. Any preferences? Anybody want to volunteer? Or are we just going to stick with games and reviews? All right. Okay. We will stick with games and reviews. Thank you for your feedback. All right. So I'm going to kind of just go through the steps. So anytime you're creating a new model, anytime you want to work on a new model and connect it to Active Record, we're going to go through basically the same set of steps. It's kind of like a step 0, which is to set up the environment. So kind of all of the files that I walked you through, we have to make sure that is set up for any project that you want to work on that uses Active Record. We're never going to make you write that from scratch. We will always give you like the environment setup. But in case you're trying to make your own project, just make sure that is there. You can copy the files, the structure that we gave you from some other projects, but you will need that in order to get all of this to work. So need to make sure the environment is set up. And then the first step will be to write a migration. So a migration is a set of instructions for manipulating the structure of the database. All right. So anytime you're talking about creating a new table in the database or changing the columns on the tables for a database, anything that is kind of affecting how the database is set up, we need to write a migration. We need to write like a set of instructions that will tell Active Record how to do that in the database for us. All right. I'm not going to go into like DB browser for SQLite, manually create these tables. I'm going to write some Ruby code that will do that for me. Right? And by writing that code, by writing it in this special way using a migration, but not only will that do what we want in the database, but also like Active Record, this gem that we're going to be using, will be aware of how our database is set up. So we are going to write a migration. And to automate that for us, so I don't have to write as much of this like boilerplate code, we're going to use one of these rake tasks. So if I want to like create a new migration in our database, does anybody see a rake task that would be appropriate for that? Yeah.
Rake DB migrate, create migration, sorry.
Yeah.
And then you write the name.
Yes.
Name and then the name of your file.
Awesome. Yes. So rake DB create migration. This will write some code for our migration for us. So this will give us like a starting point for where we want to make these instructions. So if I call rake DB create migration, if I don't say anything else, it's going to tell me I'm like using this wrong. It gives us like a really helpful error message on how to actually run this rake task. So if I want to create a new table, if I want to use this to create a table, right, this is the example usage that they give us. So this is how they expect us to run this command. So I can do rake DB create migration, and then I need to give my migration a name. I need to identify it. I need to say like, what is this? What are these instructions for? So I'll say these are our instructions for creating the games table. And by writing that, right, what it does, it creates a new file for us. Right? Creates a file called create games, so whatever we say for the name here. It also gives it a timestamp. So it says, specifically this is when this migration was created. And this is very important for, the order that these migrations are created, the order that we give these instructions to the database is important. So having this timestamp will indicate that. And it creates this Ruby file in this DB folder under a folder called migrate. So all of our migration code, all of our instructions for how the database should be set up are going to live in this one place. Okay. And this is the code that it sets up for us. It says it's going to write some Ruby code, right? So it's creating a class, create games. Right? The name will match with the name that we gave it here. It's inheriting from Active Record migration. So we get a bunch of like methods, we get a bunch of code from this Active Record migration class. And we're going to give it some instructions for how to change the database. So at this point, I'm going to refer back to like the Active Record migration documentation. Active Record is like originally developed as part of Ruby on Rails, and there are really, really awesome documentation for everything related to Rails. So I'd say like get in the habit of anytime you're working with Active Record, this should be like your Bible. This should be the place that you check for how things should work, for finding out about new features, things like that, seeing what you can do with this code. And this is also where I just like find examples for what we can do. So this is like a very common thing. If we're trying to create a new table, this is like the first example that comes up. So this is how, if we were creating a products table in the database, this is how it would work. So I'm just going to steal this code and figure out what we need to change to get it to work for our domain. So we are creating a games table. So I'll say this is create table for games. And the one thing about Active Record is like naming conventions are really, really important. So anytime you're creating a table for a class, the table name needs to be plural, class name needs to be singular. All right, so we've always been giving our classes like a singular name. So when we're making this class, it will be the game class. The table in the database will be the games table. Right. And then inside of here, inside of this create table, we get access to this table builder as the block parameter. And the table builder has a bunch of methods for creating columns on this table. So the columns will be like the kind of primitive data types that we can use for SQL. So when I say like t.string, this is calling a method of string on this table builder, and we are passing in a symbol for what we want the name of this column to be. Right. So if I wanted to say like this is the title for the game, we could say t.string, pass in a symbol for title. One thing that always trips people up, and like I still forget, is what order should these go in? Should I be like t.title and then say the data type of string? If it helps, just remember that these are all like methods on this table builder, and there's no way that Active Record could know about all of the possible column names that we could ever give. Right. So it knows about all of the data types that it can work with. It knows about strings, so it has a method for strings. It knows about integers. It has a method for integers. It knows about booleans, so it has a method for booleans. It doesn't have a method for like titles.
You can create one of them, can't you?
We could, but in this context, it wouldn't help. It wouldn't help us. Yeah. Okay. So this is just kind of like the boilerplate code that we're going to write for creating columns with these data types in the application. Okay. So let's make a title. Let's make a genre, and we'll do integer for the price. You will very often see these written just with spaces rather than the parentheses. Ruby lets you call methods without parentheses. It's very weird, but this is kind of like the Ruby convention. I think it reads a little bit nicer. We're like creating a string column for the title. So these are going to be the different attributes, the different columns on our games table. This last one, this like t.timestamps, it's nice to have, so I'm going to leave it. It will basically create two additional columns, one for the like created at and one for the updated at. And these will just be timestamps that say when this row in the database was created and the last time it has been updated. So I'll just leave it in there so you can see what that does. Awesome. So we have created a migration. The next step is writing the migration, create a migration. Next step is write the migration. And I'll make all of these notes in the lecture repo, so when you're following these steps, like when you're setting up your classes, you can just walk through the exact same process. So create, so this is our rake task. So after we have written the migration, we need to actually tell Active Record, tell Ruby to run these instructions. So we need to run the migration. Right. So we basically like created a set of steps for how our database should be set up. In order to actually get the database set up, to actually create this table in the database, we need to run this migration. And the way we can do that is by using another rake task. So similar to how we could use rake to create a migration file, if we want to run all of these files, if we want to run all of the code in this migration folder, I can run rake db migrate. Awesome. So by running that, by saying rake db migrate, this is going to look for all of the new code inside of this migration migration folder. It will run these instructions, and it will update our database. So it created this like development.sqlite database. If I look at it, if I like open this in our DB browser, you can see there is actually like a games table that has all of these different columns that we defined when we were setting it up. All right, so this creates the physical table in the database for us. One thing is like also very important is anytime we're creating a table, it will automatically get this ID column, so you don't have to add that as part of the migration. This will be done for you. So we'll get that primary key that will uniquely identify the row in the database that we're working with. So the other thing it does, right, besides altering the database, besides adding these tables, is it creates this schema.rb file. And this file is like super important. This is basically a snapshot of what our database looks like and how Active Record knows how our database is set up. So in this schema, this should be the first place you check if you want to see, did my migrations run successfully? Is the database set up with the columns that I expect it to have? Yeah.
Yeah, it's funny because I didn't, like, I know that, like, Ruby doesn't use the word term null very often, but I see it here.
Mm-hmm.
It's usually seen in, like, Java stuff like that. And, like, null, what does null mean here?
So null is a special value for the database, and it basically means nil. It means there's like nothing here.
Okay.
So yeah, there's like a lot of different configuration you can give to these columns. Like if you wanted to say, when you're setting up this column, don't allow any empty values, don't allow null, you can tell it, you know, in your migration, set null to false, right? Don't allow null values in this cell in the database.
Creating migration.
Yeah.
Like after main.
Yeah, so like there's additional setup, additional configuration you can give to your columns as part of the migration. I would say like if you're curious, if you want to see more of what you can do, this is the place to look. This is the place that will tell you like how to do those configuration steps. Yeah, but yeah, this schema, this is kind of like the living document of how Active Record thinks our database is set up. And once we get to like actually working with the classes, this will be our new, like, these are now our attr accessors for our classes. These are how we're going to be able to reference like rows in this table. Couple important things about the schema. One is just you should never, ever, ever update this directly. Anytime you want to change how the schema is set up, you need to change your migrations or create a new migration. If you like update this manually, things will break. So please don't touch this. This is just for looking, not touching. Another important thing for the schema, it's always going to be labeled with like a version. And the version will match with whatever the last migration file's name is. So the current schema has a version of like 2020-01-16, this timestamp, that will match the file name for this migration file. So once we start creating more migrations, we'll see how this changes and how this is affected, like the version of our schema. All right, cool. So let's see, what do we have? So this was run the migration. This is by running like rake db migrate. And there's kind of like a step 3.5, which is check the migration. So make sure your migration did what you expect it to do. You can check by looking at the schema. You can also check by calling rake db migrate status. And this will just tell you, was your migration run successfully? So if the status of your migration file is up, that means it is like currently part of the database. All right. Last thing we need to do, all right, we've got our table set up. It has like the columns that we want that will define like the attributes of a game. Last thing we need to do is create our model. So create model and connect to active record. So in this models directory, I'm going to create a file called game.rb. So following the naming convention, this will be a class of game. If I just look at this now, if I like go into our console and I just look at the game class, right, just to make sure I have access to this class of game. We haven't written any code in here. We haven't connected it to active record yet. But if I look at like how many methods it has right now, just by nature of being a Ruby class, it will have a bunch of methods. If I look at how many methods there are, if I just want to see how many methods we have access to, there's already a lot. So 171. Keep that number in mind. Next thing I need to do is inherit some additional functionality from active record base. So this active record module has a base class, and this class is what all of our models will inherit from. So we're now inheriting from active record base. Previously, there were 171 methods. If I look at game.methods now, drum roll please. All right. All right, so the next couple days are going to be about learning those 400 and sorry, not that many. So yes, we get a lot of functionality by inheriting from active record base. So I'm going to cover like some of the key functionality related to CRUD. All right, how are we doing on time? Cool. All right, so before we start like manipulating this class, before we start actually seeing what we can do now that we have this access to all these methods from active record, any questions so far on like the migration process, any of the steps for setting things up in our database? Yeah.
So for schema, we're going to go over when we update it later, like what the schema is going to look like.
Yeah, so we'll start like adding more classes and like altering columns, and at that point I think it'll be clearer about how the process of migration works and how that affects the schema.
Okay. Does it replace the one, or does it create a new, I guess, does it show a whole new schema with a new timestamp?
Yeah, it'll just like once we start adding migrations,
Yeah.
if I added another table, it would just add a second,
Oh, I see that.
second
Okay.
file in the same schema.
Cool.
Yeah. Cool. Okay. All right. So let's take a break here. Let's come back at 10:23, and we'll start doing this like CRUD functionality, seeing what we get from active record in our game class. Oh yeah, so Active Record, a whole gem of Active Record has a lot of different classes associated with it. So like one of the classes is base, one of the classes is migration, and basically like Active Record is a module. Right? So one of the things I think Otha showed during that inheritance record is you can use modules as just a way of namespacing different classes. Right? So in case we had our own base class, and I wanted that class to be distinct from Active Record's base class, this is a way of saying this is part of like Active Record's code. Yeah. Cool.
Can you make your shell a little bigger?
Yes. Yes. Sorry, I was just grabbing some of the code from yesterday. Cool. So yeah, so this is like basically the code we wrote yesterday for our persistence when we were saving things to the database. This like save method. So I had to like, okay, welcome back. so basically like when we were writing our own ORM yesterday, I had to make, we had to make our own save method that we could call on instances of our classes if we wanted things to get persisted into the database. So I had to write out the string, I had to say, or I had to insert into the games class these different values for these different columns. Right? This was a method that we had to write ourselves. From Active Record, we get a lot of that code for free. Right? So I'm going to go over some of the methods that we get based on like using CRUD with Active Record. So let's see, let's make a new game. So if I just say like game equals game.new right now, what's going to happen? Argument error. Cool. Something else. Let's find out. Cool. Interesting. So I didn't make an initialize method. I don't have anything in here that says like attr, writer, attr anything for ID, title, genre, and price. But somehow that is all here. Yeah. Sorry, I didn't catch that.
I'm sorry. Active Record is initialized.
Yeah, so Active Record, right? We're inheriting from Active Record base. Somewhere on Active Record's base class, there's a def initialize that we can call on our instances. Right. And where is it getting these like different attributes from? How does it know, like for our game instance, that it should be associated with like a title, genre, any of that?
It's
Yeah.
Reading the schema from the other file.
Mhm.
Active Record keeps up with it.
Yeah, so Active Record knows about our schema. It knows that we have a table called games. Right? It knows that we are in a class of game. And by making that connection, by following those conventions of using the singular class name and the plural table name, it's able to like look into the schema and figure out which table should be associated with this class. Right? And from that table, we've defined these different attributes, we've defined these different columns. So we get access to all of those as like attributes for this game. Right?
Can we see what's at the top of this file real quick just to refresh our memories, or on the schema file?
This is it. Oh, so this
like
is
what's
all the
above it?
schema.
That's it?
Yep.
Okay.
This is everything.
I'm wondering where exactly is it connecting to the game class?
So it's really just through the convention of the table naming.
Okay.
Right. So I know, right, we have access to the class of game. Like I could imagine this is how it's working under the hood.
Mm-hmm.
Right. I'm in the game class. If I get like game.toString dot downcase, right, and I wanted to get the plural version of it. Interesting. Right. And this like pluralize method, this is actually something that Active Record builds into the string class for us because these naming conventions are so important. So it needs to know how to pluralize English words. That's not like part of Ruby's code. That is code somebody for Active Record had to write. So on any string in Active Record, you can call the pluralize method. So I could see game.pluralize. This is the longest word. I'll get there eventually. You can also get the singular version of something, which is an even longer word.
No.
So much better that time. And it knows about some like edge cases. So if I wanted to see the singular of mice, it knows that is mouse.
What about fish?
Let's see. So we want to do like fish dot pluralize. Let's see. Interesting. Right.
Wow.
So people handle a lot of these edge cases. They route a lot of this code. It's not perfect. Like one we could do is like man dot pluralize men. But if we do Batman dot pluralize Batman or human dot pluralize. So it's not perfect. So if you have anything that's like not a regular or I don't know, anything that's got an irregular pluralization, try to be careful with that when you're naming your tables in your classes. There's ways to configure it. There's ways to change, how it finds the table name. And if you need to do that, just talk to us. We can help out or try and figure it out.
So under the hood, is it using that like keyword, like when we did the Mario Kart thing? And it's like
Not quite like that. I think it's really using the class, the actual like class name, so the name of the class in Ruby, and then the name of the table in SQL.
And that's why you say the naming conventions are so.
Yeah. So naming conventions, very, very important for following this like singularization, pluralization. But all right, we still have access. So at some point I made a game. All right. And even though in this game I didn't create any like adder methods, I could still like set the title. So what's a game somebody's playing or would like to be playing? Hands. Yes.
Can we finally get a Half-Life 3?
Sure. It's Half-Life 3. So nothing broke. I didn't write this method. Active Record found out, that I have this attribute, this column on the table, and it made this writer method for me. Right? It also made the reader method for me, so I can get game.title. We could do basically any attribute, so I could say, what's the genre for Half-Life 3 going to be? if we were fantasizing here. Is it going to be a sports RPG? I don't know. Right? So I can set all of these attributes. And then the same way we wrote this save method yesterday, we wrote like an instance method to save something into the database. Right? From Active Record, we get that save method for free. So when I call like game.save, it will write this insert for me and say any attributes that you've changed of this game, right, we're going to save that into the database, create this new row. Okay. So we get, for create, a game.new method, which will create a Ruby object, right? Create the instance of our Ruby object. We also get a game instance method for save, which will save to the database. So we'll persist it in our application. So even if I like quit out of Ruby, when I reload this code, when I like get back into our pry and we're finding all the games in our database, it will still be there. When I call .save, it also updates the game object with information like from the database. So now it has an ID assigned. So it has that primary key ID. It also has those timestamps, so we can see when it was created, when it was updated. So this is one way of like doing CRUD, doing like creating a new game. You can also do the combination of new and save, right? If I want to create a new Ruby object and save it to the database in one step, I can also do game.create. And this will take in a hash. So this will use that concept of mass assignment to set those key value pairs and persist it to the database. So let's make another game. Anybody else want to volunteer? Yeah.
Zelda Breath of the Wild.
All right, nice. Should we make Zelda Breath of the Wild 2, make the sequel?
Yeah.
All right. What will the genre for this one be?
First-person shooter.
FPS. Excellent. And how much is it going to cost?
$30,000.
$1,000. Priceless. All right. Well, I mean, we're getting this early release, black market prices. Cool. So by calling .create, it will create a new Ruby object, and it will also save it to the database. So game.create as a class method is calling new plus save. So for read, right? Yesterday, when we were trying to get all of the things out of the database, we were saying, I want all of the games. I want our like single source of truth for all the games. We had to write this method of like self.all on the game class to figure out, you know, how to get everything from the games table, make that connection, map those into game instances. This is another thing that Active Record will do for us for free. So I can call game.all, get back a collection of all of the games from the database. So anything that's saved in the database, I can get by calling game.all. Right. So this is our like self.all. This is the same thing we've been doing in Ruby and like object-oriented programming. We're now just connecting to the database anytime we want that information rather than just looking at an array in memory. Pretty nice, pretty nice. If you wanted like the first game, you could get the first game. If you wanted the second game, you could get the second game. I think this goes up to like fourth. Yeah, there's nothing there, but it's still a method that you can call. It's wild. I don't know why they made it like you can call that fourth. It's weird. You can also get the last game, so the last thing that was created in the database. So ways of accessing things, you can do like game.first last. From the database. All right. So these are some ways of accessing like reading data. You can also do a little bit more complex SQL logic for like finding things in the database. So one thing we could do, if I wanted to find a game with the ID of 2, I could call game.find, passing in the number for the ID. Right? This will give me back Zelda Breath of the Wild. So game.find takes an ID as an argument, and we'll returns the instance that matches. I'm not sure. I don't think so. So if I tried it like this, like 2, 1. Oh, it does. Nice.
In that
Cool.
order too.
In that order. Yeah. Cool. Yeah, I haven't had a reason to do that, so I haven't tried it. But Active Record will, yeah, it will do a lot for you. Cool. So that's like one way of finding things. And find always takes an ID because the ID is the most uniquely identifying thing about something in a database. It is that like primary key. It will always be unique for any row in the database. But if you wanted to be a little bit more, I don't know, if you wanted to find by some other attribute instead of using the ID, we could say find by. And instead of just passing in like, I know we have a game of like Zelda, Breath of the, I needed shorter games. Breath of the Wild 2. If I called it like this, it wouldn't like have any way of knowing which column we're looking for on the games table. Like where is this information? So we need to pass in a hash. We need to specify we're looking for the game with the title of Zelda Breath of the Wild 2. Right. So game find by, we'll take in a hash and return first instance that matches. Yep. So if we had like, there's nothing that's stopping us from making more than one Zelda Breath of the Wild. So if I like created 2 of them, one was a first-person shooter, one was a second-person shooter. I don't know. Right. If I called game.findby, there are now 2 games with this title. So it still will just find the first one that matches. So it's kind of like Ruby's find method. It will always only return one thing. If you wanted to return multiple things, if there were like multiple games with the same title, you can use the where, which is kind of like the where in SQL. Right. And this will return a collection of all the things that match. So where will take a hash and return all instances that match. Right. You can also use where with like a string, so you can say, oh wait, why did I delete all that? I wanted some of that. Let me get it back. So instead of find by, if I did where, you could take a string. So I could say, if I wanted to use that SQL like keyword, and I wanted to say where the title was like, you know, anything that starts with Zelda and has whatever after it. You could do it like this as well. So white, take a hash or a string, and return all instances that match. Okay. So these are some ways of reading data. Lizelle, is there anything else that I'm forgetting about read? Are there any fun methods you know?
Off the top of my head, last time we did a box, it was like, you know, you have first, last, and like second, fourth. Like 40 seconds.
Right. Yes. You can also get the 40-second thing from the database by calling like game.40second. I think that's more of an Easter egg than anything useful, but it's there. It's there if you need it.
What about range? Like IV 2 to 3? Or like 1
So
to 3?
let's try it. So you want to like find
Find 1 dot dot.
1 dot dot 2, something like that. I guess so. 1 dot dot 2 would be not including 2.
Right.
No, I don't know what it's doing with that. Yeah, but you could still use like the fact that we have game.all and this returns a collection to say from this collection, give me the first, give me everything from index 1 to index 3, not inclusive. So this would be using indexes instead of IDs. Yeah.
I remember when
Pluck. Oh, yeah, pluck is cool. So if you have, do you have an example you wanna?
like if I wanted to do like game.all.
Yes.
Intending to map all of them to their titles, I just want an array of their titles.
Yeah, cool. All right, so if you have like a collection, and you want to just pick out, you know, one attribute from it. So if I have all of the games and I just want an array with the titles in it, we could do pluck, and this will give us an array. I think you can do multiple, so if the genre and the price kind of gets like a nested array, so it's maybe a little harder to work with, but might be useful. Yeah. So this would be like game.all.pluck column. Yeah, return an array with the values from the columns. Right. So a lot of power. This is like, again, a good place to just read the documentation. You'll find a lot of new methods, a lot of interesting things that you can do just by looking at like how to query Active Record. So Active Record query interface is a good place to look to discover new methods, discover new functionality that you can do. Yep.
So these methods that we're using, they belong to Ruby or Active Record or both?
The methods that we're talking about all the methods that I'm writing here are being defined on this Active Record base class. Because these are all writing SQL code for us. These are all interacting with the database, and Ruby out of the box doesn't know how to do that. So this is all coming from the Active Record gem. Some other things, I won't show these, but you can also, there's like an order method. So if you wanted to, you know, order all of the games in a certain order, if you wanted to like sort them by the title, you could call the order method. There's like a limit method. So if you only wanted to get back the first 5 from the database, you could call like .limit, passing in the number 5. So all kinds of things you can do. I think there's also like methods for doing aggregation, like summing things or averaging things that will work directly with the database rather than like pulling it into Ruby's memory. And that makes it a lot more efficient as well. So instead of like returning all of the things from the database into Ruby's memory and then doing the aggregation, as much of that as you can do in the database itself, that will save like time, that will save memory, it'll make your operations faster. Right. So some other things we can do. If I have an instance of a game, so if I say this is like Zelda 2 equals game.last. So if I grab one instance of a game, we have save to a local variable Zelda 2. If I wanted to update some properties, if I wanted to change the price, I could do like Zelda 2 dot price equals 3,000. It's gotten more expensive. Black market prices have gone up. But currently this isn't persisted to the database. Right? I can see there's like no SQL code being written off. This is only saved locally to this variable. So if you change something and you call .save again, right, this will now, instead of creating a new row, it will update it in the database. So if you have an instance, if I have like an instance of something that already has an ID, right, that Active Record knows is associated with a row in the database, instead of creating a new thing when you call save, it will update it. So anything that's changed. And it knows also just to update the things that have changed. So it knows to update just the price rather than trying to call update with all of the attributes. So game save. If the instance has an ID, we'll update that row. So that's one way of saving things. You can use the writer to set some new value and then call .save. There's like a slightly faster way. So you can also call like on an instance, you could call .update. And this will like create, like find, take a hash of what you were trying to change. So if I wanted to say the price is now 5,000 and the genre is a third-person shooter, I could pass both of those key value pairs into this update hash, and it will update both of those attributes for this game. So game update. So this takes hash. And this will update that row in the database. If for some reason you wanted to update all of the rows at once, you can also call update as a class method. So if I wanted to change the price for all of the games back to 1,000, by using it as a class method rather than an instance method, this will now update everything in the database. So if you need to do some like mass updating, it's a nice technique. So this will update all rows in the database. The last couple we'll go over are deleting. Yeah.
If you like accidentally updated the entire class or the entire database, is there a way to reverse that? No.
Yeah. So one thing about like working with the databases, there's no like undo really.
Yeah.
So it's kind of like permanent when you make these changes. It's permanently affecting these rows. I'd say, it's not super important. We'll show you kind of how to set up your initial data so you can always go back to that place and get like some initial seed data back. So similar to how we're kind of creating seed data when you're testing your classes before. But anything that you change in the database is basically permanent. That's why it's this great means of persistence. It will always be around. Those changes will be reflected to anybody who's using that database. Yes, and that's also why we will start working. When you work on bigger projects, you usually have several versions of the database. You'll have a version that you use just in development. So like while you're working on your own database, while you're like making new features for your apps, you'll be working with a development database. When you want other people to be able to use it, you'll have a production version. So that'll be the version that actually like lives in the server, lives in the cloud, lives in some place that other people can update or access. So you usually have like a playground. You have a development database where you can test things out, make some changes in a low stakes environment, and make sure that your code doesn't break anything before it goes to production. And things like that, considerations like how your database is going to be affected by the code you write are particularly important when you're updating or deleting things. So let's talk about these delete options that we have. So I still have access to Zelda 2. This is our second Zelda. There are kind of two Zeldas in our application now. So let's say I wanted to delete this one, get rid of this duplicate. So if you want to delete something, in Active Record, you call destroy. It's very harsh. It's like you just gotta blast it off the face of the earth if you want to destroy this thing. You can call delete. There's like a delete method. I'd say always you should use destroy. There's some subtle differences between the two, but destroy will, I would say, be the one that you want to use. And this will actually like delete this row from our database. So if I look at like game.all now, there's only one Zelda Breath of the Wild left. So game, if we call the instance method of destroy, and I promise you like 90% of the time I type this as destory, and I bet you will too. So be careful with the spelling there. So this will delete one row from the database. You can also, if you want to get rid of everything, if you want to start from scratch, if you want to get rid of all the rows, you can call it destroy all. Right. And this will delete every row from this table. So this is helpful if you've been like playing around, if you've created some stuff but you want to start from scratch, get rid of everything, and start again. You can call destroy all. Cool. So all of this code we get from Active Record. These are all methods that we don't have to write ourselves anymore. Like you can still absolutely, and you still should write custom methods in these classes. You should write your own functionality. You get a lot from Active Record, but it's not going to do everything that you need for your app. So you're going to have some functionality, some user story, something that you want your app to do that is not going to be covered by these methods. I'd say you should still be able to leverage these methods. You should still be able to use this in your code, but also get comfortable writing like custom methods. All right, let's see how we're doing. Cool. So we got 10 minutes. Okay. Any questions on like the CRUD code, any of the methods that we've been writing in here so far? Yeah.
Explain again how it interacts with SQL or the database.
Yeah. So by inheriting this class from Active Record base, Active Record follows this like naming convention, and it knows that this class of game is associated with the games table in our database. And since it has access to knowing how that table is set up, since it knows through the schema how our games table is defined in the database, it can make some assumptions about what we want to be able to do with the games table, right? We want to be able to get the title from a game, set the title for a game. We want to get the genre. We want to use all of these different columns in our database as the attributes of our game instances. So really just by following these naming conventions, by setting up table names that have the plural of our class names, it's able to make that association with the database. Okay. So since we got a little time, let's get practice doing one more series of like setup for another class. So we're just going to walk through the same steps of creating the migration, writing the migration code, running the migration, checking it, and creating a model. And we'll do that for our players class. So this is like the relationship we're setting up is a game has many reviews and a game has many players through reviews. Tomorrow's lecture, Lizal's going to go over associations. Might be a different domain. I don't know. We'll see. She'll talk about how to create relationships between the classes. So for now, we're just going to focus on creating classes that don't interact with each other. All right. So same set of steps. We're going to create a new table. And we're going to create a table for players. So first step, creating the migration. This will be for our players table. So a good naming convention to follow is if you're creating a table, we'll call it create, and then give it the name of the table that we're creating. this will create a migration file for us. And one important thing is this file has a timestamp to it. And so it's going to show up below the other file that we made. It's going to be later in time. It's going to have a higher version number than the previous version. So inside of here, we're going to create another table. So this is our create players. So we're creating table for players. Let's say a player has a name, a player has an age. Let's leave it at that for now. We'll see, if we want to like change this at some point in the future, if we make a mistake and we want to add more columns, we can see how to do that. Right. So we've done 2 steps. This gets a lot faster with practice, just knowing what the steps are for setting things up. So we've created the migration, we've written the migration code. That next thing we need to do is run this migration. So when I run the migration, one thing you'll notice is it only actually runs the new code. It only runs the code for the versions that are higher than the version it had previously. So it's only running the code for creating players. It's not going to go back and rerun this code for creating games.
Really quickly, is this where the scheme is updating?
Yes.
All right.
So yeah, so after we run this RakeDB migrate, this will update the schema.
So
It
that's
will-
where we update our table.
Yeah, so yes. So if you need to make changes to the schema, adding migrations is the way to do it. But yeah, now we have this table for players in the schema. We have a new version number, so this new version number will match the new migration file that we created. One thing you'll note is, like, let's say I made a mistake. I want to add some more columns to this players table. Like, I wanted to add, what is your preferred console? And I may want to make it a string. Does this look right? What did I mess up?
No, it's
No.
got flip flop.
Gotta flip it. Yeah. See, I still make that mistake. Sometimes I make intentional mistakes. Sometimes I make unintentional mistakes. I'd say that was an unintentional mistake. But it's a good demonstration of it anyway. Okay, so I make another attribute. I want to add this string of console to our database. What's going to happen if I run RakeDB migrate now?
Should update the
It's
scheme.
gonna update the most recent
Cool.
class
So
you created.
let's say hands for, is it going to update? Is it going to not update? Let's find out. So it's like a 50-50 split. Cool. So it didn't break, but if we look at the schema, there's no new column on our players table. Right. So since this version of the schema matches this number, basically what Active Record thinks is like, all right, I already have the code in that schema file. I'm not going to look at this one again. I'm not going to try and rerun it. And if we look at the status, if I look at like RakeDB migrate status, it'll say both of our migrations are currently up. And if the migrations are up, that means they are part of our database, they are part of our schema, and Active Record is not going to try and rerun those instructions. So if we want to take the migration down, if we want to say, I want to undo this so I can make some changes in this file, what we need to do is called rolling back the migrations. So if I do RakeDB rollback, this is going to try to undo the last step. And since the last step was like creating a table, like it knows how to undo that. It knows how to drop a table. If you have a table with players, I know how to get rid of that table. So it'll call drop table for players. And if we look at the status now, it'll say the first migration is up. So our games migration is up. Our players migration is down. So this migration is currently not part of the database, and it is not part of the schema. So since it's not part of the schema, since it is down, we can edit this, we can make these changes, we can add the console. And now that we have this down, we have this editable, I can add this console string, run the migration again, recreate this table with these new instructions, and add this additional column to the table. Yeah.
Let's say you have a bunch of different migrate
It always goes in order. So it's going to find what is the most recent version and then run everything after that version.
So, is it possible to take it all down at the same time?
Yeah, so if you need to roll back more than one, more than one migration at a time, like let's say I also wanted to change something in this games migration, one thing you could do is call rakedb rollback and say the number of steps you want to roll it back. So I could say step equals 2, and this will roll it back 2 steps. It will drop both of those tables. So currently both of these migrations are down. Our schema is totally blank, and I can edit both of these files. So if I wanted to make some other properties, like give it a string for a publisher, can make that change, migrate it, and recreate these tables. So why is this whole migration and rollback thing in place? This is kind of annoying, right? I say yes, it is kind of annoying, and there are some, basically some like best practices to follow in terms of when you need to roll back, and when you can just, when you can get away with rolling things back. So basically, if you're the only person who's been working on the code since the last time it was edited, you can roll back as many times as you want and make changes to the migrations. Let's say you're working on this with somebody else, right? Let's say I'm working on this project with Lizelle. I've made some tables. I've made these migrations. These are currently like set up. She's also working on the code. She's under the assumption that these tables are set up in this specific way. At that point, like since we both have the same definition for how the database should be set up, if I wanted to make some changes, I shouldn't roll back. I shouldn't just like roll back the changes and edit these migration files. At that point, I should create a new migration that would like add columns to a table. So I'll show you that as well. I think we got we'll do a couple minutes worth. So in addition to being able to run this create table migration, there's other migrations that will let you alter columns, change how tables are set up. So there's one that is for adding column. So let's say instead of rolling back, if you wanted to add a migration whose only job was to add an additional column to a table, you could write a migration like this. So let's say Lizelle and I both have this code. Our tables are set up where we have like a games table with these 4 attributes and a players table with these 3 attributes. And I wanted to create another migration to add a column to one of these tables. I can do rakedb create migration. I still need to give it a name. And this should just be something that describes what we're trying to do. So let's say this is add, I don't know, add, what's something we could add? I'm totally blanking.
For both of them?
Yeah, for one of them.
Add a rating for the game.
Cool. So add rating to game. Thank you. So this will create a new migration, right? And we can use this migration to, instead of like creating a whole new table, just to add a column to one of our tables. So this will be add a column to the games table. Second argument, if you had to guess, what would you think this argument was for?
Like what column it's in?
Mm-hmm. Yeah, this would be like the name of the column we're trying to add. So this would be like the review column, or what do we say, rating?
Yeah, like rating, like
Yeah. And then what would this last argument be for?
Probably integer or real.
Yeah, this would be like the data type, so the integer for this. Right. So now, if I look at the status of our migrations, our create games is up, our create players is up. We haven't run the migration for adding a rating to a game. So our schema currently doesn't know game should have a rating. As soon as I run rakedb migrate, it will add that to our schema. And now we've basically safely updated our database. So the next time Lazal wants to work on this code, she'll have this new migration file. She can just run the migration and get it to update the database. So we both have the same setup. Yeah.
Is that kind of like adding a new instance variable or a new attribute to an instance?
Yeah, so this would be, anytime we're talking about adding columns to a table,
Yeah.
the way that Active Record is going to treat those columns is like as attr accessor methods, right? So we'll be able to read and write these values to an instance variable. Mhm. Yeah.
So if you didn't want to roll back, but you didn't want to create a new migration file, would you be able to manually go into like the game.rb and write like a reader?
So you can still add attr readers, attr writers to your classes, but if you add them, they won't be connected to columns in the database. Yeah. So basically anything that you want persisted, any data that is part of your classes that you want to be saved to the database, it should be part of your schema. It should be one of these columns. Yeah.
I assume there's probably a way to like merge some of these. Like if you're gonna do the like add a column thing, probably at some point you'd want it to just like be part of that original file.
So
the original migration.
no, so really you want the migrations to always reflect the series of changes that your database went through.
Okay.
So the migration should always, really like once you start working on the project with somebody else, instead of rolling back, instead of changing the initial like create table migrations, you should start working on like using the add table or add columns or alter columns to update the database. One reason for that is like when you actually start working in this code in like a production environment as well, these same set of steps that are creating your development database are going to be used to create your production database. And by having that same process of knowing that I've written this migration, the migration will change the database in the way that I want it to. I can do that locally. I can test it in my development environment, make sure that the new database looks like I want it to. And I can also make that incremental change in production. I can just change that one small piece rather than needing to like blow up our database and recreate it from scratch.
Does that relate to version control then?
Yeah.
Where it's like you're just like adding a new migration and
Mhm.
slowly updating?
Yeah, I think that like version control, thinking of the schema as version control for our database is a really good way of thinking about it. It's like these are kind of our commits, right, for the migrations. These are how we've changed our project over time. What was I saying? There was one last point. It's gone. I don't know. Yeah, so get in the habit of trying to use some of the advanced migrations, let's say, to update your database rather than rolling back and changing things. It's good practice to get into. Yeah.
I know that in the schema you don't see the unique IDs.
Right.
How would you connect the two tables?
That'll be tomorrow's lecture. Yeah. Yes, we'll get into that tomorrow. Cool. Yeah, I'm just going to do this last step so we have it. So we've created our tables for games and players. The last thing we need to do to set up our player class, right, is create a class of player and have it inherit from active record base. Right, and then all of the same things we were doing in the game class, all of these CRUD actions, we can do the same thing with our player class. Yep.
Do you have to save that or anything, or is it just gonna work the next time you work with the instance? I don't really know how that's done.
Yeah. So as soon as I go into my console, as soon as I start being able to run code as part of this project, right, I have this player class saved. We have our player table set up in the schema. So I try to call like player.new, and it's connected. All right. Cool. So I think, yeah, we have deployed this morning all of the active record labs. This is going to be all the labs that you have to work on for the next couple days. tomorrow we're going to be giving out project groups and talking about like the project you're working on for next week. We'll try to have some Mod 2 students come demo their CLI apps because there were some really good ones last time, so you can see what it looks like. And yeah, and Lizal, like I said, is going to be running tomorrow's lecture. That will be how we tie in this last step of connecting between classes, creating relationships in Active Record. All right, that's all I got. Thanks, everybody.